Hello everyone. Sometimes when we're making a comparison between two groups, we want to see that. We want a visual representation of how those groups differ. So, a lot of times, we'll make a plot. We'll make a different chart to show the mean, to show the variation, and that's what this video is all about. So, we're going to take a data set that I've already started to look at, and we're going to make a graph from those data to show the way that variation compares, to show the way that the means compare. So here are our data. These are the original data for the control and treatment groups. So here's the mean or the average, the median, the minimum and maximum, so the range, standard deviation, standard error, and a t-test that shows that these two groups really are different. So let's get started. We're going to go in and we're going to create a column graph, and we're going to use not the individual values here, but we're going to use the calculated means for those groups. So that's going to give us a summary of the information. You'll notice that this chart is not set up in a lot of the ways that we normally see in a scientific publication or in a professional report. So the first thing we're going to do is get rid of the chart title. The other thing that we need to do is we need to label the axes. So in Excel, we can do that fairly easily. One way to do that is to go to this little plus button and go to Chart Elements. We can also hop up here in this ribbon to add a chart element, and we can go down to Axis Titles. So we can add one to the primary horizontal and the primary vertical. We definitely need the primary vertical, and in this case, let's pretend like this is height. Okay, great. Wait. Height? Is that between 5 and 6 centimeters or between 5 and 6 meters? Okay, right. So we should always make sure that we include some unit of measure. And sometimes you're going to be graphing things that are unitless, and that's okay, but you need to make sure that you clearly communicate that. Whenever there's a unit, it should always be there. So let's pretend like these are seedlings. Centimeters would make a lot of sense, right? 2.54 centimeters per inch. It seems reasonable that we're going to have these fairly short new plants. And in a lot of cases, we'd really like to have an x-axis as well. There are some cases where it's not necessary. I'm going to go ahead and put it on. And these are our experimental groups. Experimental group, because we're referring to each one of those columns separately. So the next thing is that we usually want some measure of variation. And a lot of times, we really want to know how close that mean is to the real mean for the population. So we're asking, are these really different? And we might put in, for an observational study, the standard deviation. If we're doing an experimental study, we're more likely to put in the standard error, and we want to know basically that mean really truly is different from the other. So we can go back here, run down to error bars. The problem is that Excel will calculate the error bars differently than most of the places that you'll see, than most of the ways that people represent those error bars. So we need to do this by hand. And you'll notice when Excel does this, it gives us one standard error for the whole thing. That's not right. Each one of these, each of our control and treatment came from a different place, right? Those data are different and maybe fundamentally different. So they might have different amounts of variation. It might be that we're closer to one mean than the other. So we want to make sure that we're putting appropriate error bars on there, and that they're different for each one of those groups. So Excel is going to give us some choices. We could have an error bar above the bar, just below the bar, just above the bar. In general, you want to put an error bar both above and below. And right now we have it at a fixed value. We could do a custom error bar, and if we cared mostly about the range, what's kind of cool is that we could do the maximum above and we could do the minimum below. And so that could tell us something about the data. For the most part, we're probably comparing those means, and we want to have an idea how close our measurements are to the real means for the population. Right? So we've taken a sample and we want to represent how close those means are to the real mean for the population. So let's go back in here again, and we're actually going to choose the standard errors that we have already calculated. And that's going to show us how close each of those bars is to the means for the control and the treatment respectively. And so this is going to give us a much more reasonable representation of where those means are. And the nice thing is that this gives us sort of an informal way to compare those groups. We know that the t-test says that they're different, and we know that the standard error of the mean tells us basically how close we got in our samples to the real mean based on these data. And guess what? That standard error doesn't overlap. So a quick visual inspection of these data says that that agrees with our t-test. There are some cases where those kinds of quick examinations aren't going to really do it for you. But in this case, they agree. Awesome. And now we can think about moving on to the next step and including this graph as well as these statistics into a paper or a report. So that's a quick look at how to create a graph in Excel and to show some form of variation. We looked at how to show the range, and we looked at how to show the standard error. If we chose to do the standard deviation instead, that would be easy enough to do too. We do it in the same way as the standard error. For a lot of the things that you do, especially in classes or in simple experiments, you're going to use the standard error. So I hope that this video helps you and that you have a great day. Thanks for listening.